Hello and welcome to Cashmatics. In this lesson, I'm going to show you how to factorize the different types of quadratic expressions you might come across and how to solve quadratic equations by factorizing. Now I'm going to start with the easiest ones, but the ones that people make a lot of mistakes with because they make them more complicated than they need to be. And then I'll move on to slightly more difficult quadratic equations. Now you might need to pause the video from time to time to make notes, but by the end of it, I'm hoping you'll have a much more secure understanding of the topic and you'll be able to go on and answer some questions which you're almost certainly going to be tested on at some point during your math studies. So as always, grab yourself some paper and a pen and let's get started. The first type of quadratic expression I'm going to factorize is this type, and you'll notice there's no constant at the end of any of these. Okay, there's only an x squared term and an x term, and the mistake that people often make is they try to factorize this into double brackets when in fact you just need one bracket, and I'll show you what I mean by that. Now this first one here, what I need to look out for is a common factor. So I can see there's an x inside this x squared as well as an x inside this 2x, and that's the most I can pull out of the brackets. So let's put an x outside of the brackets. And inside the bracket I'm going to need two terms because I've got two terms in the expression. So x multiplied by x gives me x squared, and x multiplied by 2, so x multiplied by 2, so this one multiplied by this one, would give me the 2x. And because it's a positive 2x, that would have to be a plus 2. Now over here it's slightly different because I've got a number which is common as well as a letter. So 4 is a factor of 4x squared as well as 20x. And the x is also a factor of both terms. And inside the brackets I need an x to make 4x squared minus to make a negative term because this is positive, positive times negative is negative, and that just needs to be a 5. And the last one, very similar, the common factor is 5x, and hopefully you can see that. And I need a 3 to make the 15x and a minus 4x to make the minus 20x squared, because 5 times 4 is 20, x times x is x squared. So that's how you'd factorize these expressions. Now if instead of an expression it was an equation, so let me just get rid of this equal sign over here and make these equal to 0. Okay, so I want to make all of these equal to 0. The first step would actually be the same. You'd actually factorize each expression. But then what you need to consider is that each of these factors could be 0, because only 0 multiplied by another number would be 0, which means either this is 0 or this is 0. So if x is 0 over here, it's as simple as that. And if x plus 2 is 0, that would mean x would have to equal minus 2. So if you just try to solve this really simple equation by moving the 2 to the other side, you'll get x equals minus 2. So these are your two solutions to that equation. Similarly over here, you got 4x equals 0, which means x would have to equal 0, because 4 times 0 is 0. And over here, you would get x minus 5 is 0, and x would equal 5. Okay, and sooner or later you'll be able to do these without having to do this first step. You'll just be able to write these down as soon as you factorized it. So from here 5x is 0, which means x has to equal 0. And from this, now this one's a little bit trickier. 3 minus 4x is 0, which means 3 is equal to 4x. Okay, so move the 4x over to make it easy to solve. Then divide by 4, so 3 over 4 is equal to x, which means x is equal to 3/4 and x is equal to 0. Now in the next slide I'm going to set you some questions, so let me just put those up. Okay, there you go. There's 4 questions for you to try which are very similar to the ones you've just done. So if you need to go back and pause the video on the last screen and make some notes. If you think you've got it, just pause the video now, because I'm going to put the answers in a few seconds and then you can check to see if you've got them right. So I'm going to reveal the answers in 3 seconds. 3, 2, 1, and there you go. Okay, so I hope you've got those right. If you haven't, then I suggest you go back and watch the other examples first, well again, and then come back to these questions. Now these next examples I'm going to show you are the ones you're most likely to be used to seeing. So Before I go through them, what I'm going to do is just give you an example of expanding brackets. So hopefully you'll be able to see where everything is coming from. So let's have a look at an example. So if I had x plus 2 multiplied by x plus 9, for instance. Now, if I did expand the brackets, which if you don't know how to do, there's a video on expanding brackets. What you'd get is x squared plus 11x plus 18. And what you need to understand is where this number comes from and where this number comes from. So the 11 comes from 9 plus 2. And the 18 comes from 9 times 2. So what we need to look for when we're factorising is factors of 18 which also add up to 11. Okay, so we need to do the backward step. So we need to look for factors of 18 which add up to 11. So that's the thing you need to remember. And the other thing that you need to remember is this technique only works if you've got a single x squared term. If you've got 2x squared or 3x squared, that won't work. Okay, we use a slightly different method. So let me just show you once more. So imagine I had x plus 11 multiplied by x minus 3. If I expand the brackets, I would get x squared plus 8x take away 33. Okay, now you've got to be careful about the signs here. This is a minus 33. Now what I do is I just consider the factors of 33. So you've got 1 and 33 and 3 and 11. I don't worry about the negative just yet, but what I'm looking to see is how can I use these to make 8. And I know I can do 11 take away 3 to make 8. All right, so I know I've got the factors. I can't make an 8 from the 1 and the 33, but I can from the 11 and the 3. 11 take away 3 is 8. So when I'm factorising, I know the 11 has to be the positive one. So if I compare that to this, that's a positive 11. And the 3 has to be the negative one. So compare that to this over here. All right. So let me just do an example which is the right way around. So let me just get rid of this. And let's just put one on the board. So let's say we've got x squared plus 4x plus 3. Okay, and this is a nice easy one because 3 is a prime number. I've not got any options other than 1 and 3. So what I do is I open my brackets and I put the 3 in and the 1 in, and because 3 and 1 does make 4, 3 plus 1 does make 4. So it's a positive 3 and a positive 1, which makes a positive 4. All right, let's just do one more over here. In fact, I'm going to do several more. X squared plus 3x minus 28 equals 0. So I'm not worrying about the negative just yet. Oh, forget the 0 equals 0 for now. Okay, I'm not worrying about the minus 28 just yet. So 1 and 28, 2 and 14. Sorry, 2 and 14, and 4 and 7. Okay, and I'm looking for ways I can make a 3 by either adding or subtracting. So I can't make a 3 from the 1 and 28, neither can I make a 3 from the 2 and the 14, but I can make a 3 from here by doing 7 take away 4. I'm trying to make a positive 3, remember. So all I need to do then is write my x and my x, my 4 and my 7, and remember the 7 has to be the positive one and the 4 has to be the negative one. All right. Now if instead, I'm going to change things slightly. If instead that was a minus 3x, okay, I'd still use the 7 and the 4, but how do I make a minus 3 from 7 and 4? It's actually 4 take away 7, which means the 4 would have to be positive and the 7 would have to be the negative one. So watch your signs because that can catch you out. Right, and one last one. Okay, one last one. Let's say we had x squared take away 7x plus 10. Okay, so factors of 10, 1 and 10, 2 and 5. And I need to make a minus 7 somehow. To make a minus 7, I need these ones. And it'd be minus 2, minus 5, because minus 2 take away 5 is minus 7. So in my brackets goes minus 2 and minus 5. And the thing is, I need to make a positive 10 when I multiply them. And that does actually make a positive 10. Okay, minus 2 times minus 5 does make a positive 10. So that's how you factorize a full quadratic where the x squared term is just x squared. It's not 2x squared or 3x squared. So let's turn these into equations now. Okay, like we did before. So let's make that equal to 0. Okay, now as before, the first step is exactly the same. And all I need to do now is pull out the answers. I'm going to do this by inspection. So x plus 1 has to be 0, and hopefully you can see that for that to be 0, x would have to be minus 1, because minus 1 plus 1 is 0. And over here, x would have to be minus 3. Over here, x would have to be equal to minus 4. But over here, look, x would have to be equal to 7, because 7 take away 7 is 0. Now, if you do struggle, what you can do is just say x minus 7 is 0. Remember, anything in the bracket has to equal 0. So solving that gives me x equals 7. And this one here, hopefully you've got the gist of it by now. So this is x equals 2 and x equals 5. Okay, so pause the video, make some notes if you need to, rewind it if you need to watch it again. And what I'm going to do is put some questions up for you. So here you go, 4 questions. I'll pause the video in a couple of seconds, and then you can pause it. Sorry, you should pause the video in a couple of seconds, and I'll reveal the answers in a short while. So answers coming up in 3, 2, 1. There you go. Okay, so those are the answers. Just check them against what you've got, and if you made a mistake, then just go back and try again. Okay, now these next ones are called the difference of two squares. So let me just show you what I mean by that by doing some expanding first. So if I've got a bracket, x plus let's say 12 and x minus 12, you'll notice the thing to notice here is that both brackets are the same other than the sign. Okay, the sign is different. One's a plus, one's a minus. Now if I was to expand this, I get x squared, and I'll do the full expansion, plus 12x minus 12x minus 144. So these two terms cancel each other out, and I get x squared minus 144. Okay, let's just do one more. X plus 1, x minus 1, and I'd get x squared plus x minus x take away 1. Right, and they'd cancel each other out to give me x squared take away 1. And that will always happen. The x terms will always cancel out because you'll have a positive version of it and a negative version of it, and they'll cancel each other out. And these quadratic expressions only have an x squared term and a number afterwards. Right? Now the thing to observe here is inside the bracket, that there is the square root of x squared, and this number here is the square root of 144. So if I wrote something like this, a plus b multiplied by a minus b, that would always equal a squared minus b squared. And we can use this simple fact, this is called the difference of two squares. There's your difference, and there's your two square terms. Okay, that's why it's called the difference of two squares. And I can use that fact to factorize quadratics of this form quite easily. So let's just say I've got something like, I don't know, x squared plus 16, sorry, x squared minus 16. That would equal, so double brackets, so compare that to what we've got here. Your a is your x squared bit, your b squared, sorry, is your 16. Right, so all I need to do is write down the square root of the first term, the square root of the second term, and put in a plus and a minus, as simple as that. But the order of these has to be the same as the order of these. Okay, so if instead I had something like 25 take away, well, let's not do 25, let's do a different number, because I've used that in one of my questions. So 121 take away x squared, that would be 11 and 11 for the first number, because that's the square root of 121. X and x plus minus. Okay, it doesn't matter which way around it is, whether the plus is first or the minus is first. Okay, but the numbers have to be in the right order. So let me just do one from scratch where I'm actually solving an equation. So let's say I've got something like x squared take away, let's do 169. Now it is useful if you know your square numbers. Okay, so that would give me x over here, okay, to make my x squared. So that's the square root of x squared. 169, the square root of that is 13. I just need a plus and a minus. And if this was an equation instead, if that was equal to 0, from here hopefully you can see that x would have to equal minus 13 to make that bracket 0, and from this one x would have to equal 13. Now it can get slightly more complicated than this. So let's say I've got something like 16x squared take away 100. Now if I was going to factorize this, let's do the whole thing. Let's make that equal to 0. If I was going to factorize this, I'd do the same thing. I need to do the square root of 16x squared, which is actually 4x. Okay, and for 100, that's a nice easy one, that is 10. So minus plus. And then from here, I get 4x plus 10 is equal to 0. And if I subtract 10, I get 4x equals minus 10, and x equals minus 10 over 4. Okay, and I can divide both of those by 2 to simplify it, and I get minus 5 over 2. And from this one, 4x minus 10 equals 0, 4x equals 10, x equals 10 over 4, so very similar, which means x equals 5 over 2. So I hope that's made a bit of sense. Remember, you need to recognize it's a difference of two squares. Whatever you do, don't do it for the sum of two squares. That just doesn't work. Okay, it has to be the difference, so that has to be a minus sign. Okay, pause the video if you need to make some notes, rewind it if you need to watch it again, and have a go at these questions that I'm about to put up. So as always, pause the video and I'm going to reveal the answers shortly. So 3, 2, 1, here we go. Okay, so those are the answers. If you made a mistake, go back, watch the examples again, and then just try those again. And moving on to the last type of quadratic equation, this is where the coefficient of x squared, which means the number in front of the x squared, isn't a 1. So you've got 2x squared in the first one, 7x squared in the next one, and a 4x squared in the last one. Now what they tend to do in exams is they make it slightly easy for you by giving you prime numbers. That's what they tend to do. They don't always do that. So you can see that we've got a prime number here and a prime number here. Okay, we've got a prime number here and another prime number here. But this last one here, the 4 isn't prime, but the 3 is. Okay, so that one's slightly trickier. So what we'll do is we'll follow a process which I like. Okay, this isn't one that everyone uses. Some people have another method which I can never remember, to be honest. So just try and work with me and see if you understand what I'm doing. Hopefully you will, because it's not actually that difficult, but it is different to the other types of quadratics. So the first thing I do is I would draw two brackets. Okay, and that equals 0. And I've got to think, how many different ways are there of making a 2? There's only one way I can make a 2, by doing 1 times 2. And in this one, we've got 2x squared. So I need a 2x and an x. There's no other way of making 2x squared. Okay, and the x squared term always comes from multiplying these first two terms here. So there's no other place an x squared term will come from. The 3 comes from multiplying the last two terms. Okay, so I know it's going to be a 1 and a 3, but I can't just put it anywhere. I need to put it in the right place. So if I was to put a 3 here and a 1 here, the problem with that is I need a positive 1 and a positive 3 to make a 3. Okay, so that would be okay. But the problem here is when I multiply the 2x by the 3x, I would get 6x. And when I multiply the x by the 1, I'd get another x, which is 7x. But I only want 5x. Okay, so what's happened here is I've put the 1 and the 3 in the wrong place. Okay, so let's just get rid of the 1 and the 3. And let's swap that around. So 3 and 1. Let's try it again. So the 2x times the x gives me my 2x squared. The positive 3 and the positive 1 gives me a positive 3. And here, that gives me a 3x. That gives me a 2x. So altogether, that is 5x. So I've got the right number of x's. So that means that's been factorized. Okay, so that's that factorized. And what I can do then is go ahead and solve it. So 2x plus 3 equals 0, which means 2x equals minus 3. And x equals minus 3 over 2. And with time and practice, you'll just be able to get straight to this once you've factorized it. And from this one, you should be able to tell me that x equals minus 1. Okay. Right, let's have a look at the second example. Very similar. Okay, we've got a prime number at the start, so I can start by writing x and 7x, or 7x first and then x. And I've got a 2 here as well, right? So that's prime, so I could put the 2 here and the 1 here, but I need to check Okay, I need to check something. Now, first of all, I need to look at this 2. It's actually a minus 2, right? Which means one of these has to be positive, one has to be negative. But even so, from there I get a 7x, and from there I get a 2x. With a 7x and a 2x, I can either make a 9x or a 5x or a minus 5x. I can't make 13x, okay, because 7 plus 2 is 9, 7 take away 2 is 5, or 2 take away 7 is minus 5. So that's not gonna help me having those numbers there. So let's try it the other way around. So let's put the 1 here and the 2 here. So multiplying these gives me a 14x. That gives me a 1x. 14 take away 1 is 13, so that would be 13x. So I know the number's in the right place. I've just got to get the signs right now. And because that's a positive 13, I need to make a positive 14, because 14 take away 1 is 13. So that 7x times 2 is 14x. Take away 1x, okay, or just x, gives me 13x. So that's that factorized. And then I can pull out the solutions. 7x minus 1 equals 0, which means 7x equals 1, so x equals 1/7. And from here, that's a nice easy one, I get x equals minus 2. Okay, so these are my 2 solutions. Now moving on to the last one, this one is slightly trickier. It's tricky because I've got a 4x squared there, so that's not a prime number, so I've got several choices for that. But at the end, I've got a prime number, so that's made it slightly easier for me. So let's just draw the brackets like before. Let's put in 4x and x, and let's just put a 3 and a 1. Okay, so the 3 and the 1 will give me my 3. Okay, I'm happy with that. The 4x and the x gives me my 4x squared. I'm happy with that. So I just need to check if I've got the right number of x's. So that gives me a 12x. That gives me an x. Now with a 12x and an x, I can either make 13x or 11x or minus 11x. Okay, I can't make 8x, which means that's not right. Okay, so what I can do then is put the 1 here and the 3 here. Okay, 4 times x is 4x, 3x. So with the 4x and the 3x, the most I can make is a 7x. So that's not right either. So if it's not right this way round and it wasn't right the other way round, what else could it be? And the answer to that is this 4x. Okay, that needs to be a 2x, and that needs to be a 2x, because that would give me 2x squared. Sorry, 4x squared. Right? So that term is still correct, 4x squared. I need a 3 and a 1. Now this time it doesn't matter which bracket it goes into, because they both start with a 2x. Okay, so I don't need to worry about that. But let's just check. That gives me a 6x. That gives me a 2x. With a 6x and a 2x, I can make 8x, and they both need to be positive. Okay, so that's that factorized now. Okay, so just go over that again. 2x times x is, 2x times 2x is 4x squared. 1 times 3 is 3, so that's that term sorted and that term sorted. The 2x times the 3 gives me 6x, and the 1 times the 2x gives me 2x. 6x and 2x gives me my 8x. Okay, so hopefully that makes sense now. Right, let's just get rid of this. And from here I can say 2x plus 1 equals 0. So 2x equals minus 1, x equals minus a half. And lastly, 2x plus 3 equals 0, 2x equals minus 3, so x equals minus 3 over 2. Okay, so that's those 3 quadratics factorized and solved. So digest that information if you need to, pause the video, make some notes, whatever you need to do, and then I'll put some questions up. And here we go. I've only given you 3 of these. The first one should be fairly straightforward. Okay, you've got prime numbers at the start and the end. The second one, you've got a prime number at the start, so figuring out your x squared term should be easy. But then you've got a 20 at the end, and you've got several choices for that. Okay, and the last one, you've got a prime number at the end, and you've got a 4x squared at the start, so you've got several choices for that. So this one should really test you, and if you get this one right, I'll be impressed. But pause the video, and I'll put up the answer shortly. So 3, 2, 1, and there we go. Okay, so that's the answer. Those are the answers to those quadratics. Right, so I hope that's given you plenty of practice and explained how to solve quadratic equations and how to factorize quadratics. The only thing I'll say before we finish is that sometimes a quadratic may not be in the form you need it to be in order to solve it. So what I mean by that is you might get something like this: x squared plus 2x equals 48. Now you can't actually solve a quadratic unless you've made it equal to 0 first. It's the easiest way to solve it. Okay, it's just we just wouldn't do it this way. So what you do is you make it equal to 0. Now that doesn't mean cross the 48 out and make it a 0. It means rearrange it to make it 0. So you would subtract the 48 to get x squared plus 2x minus 48 equals 0. Then look at factors of 48. Okay, that add together to make 2 or subtract to make 2. So in this case it would be 8 and 6. Okay, and because that's a plus 2x, it'd be a plus 8 and a minus 6. And then we can say x equals minus 8 and x equals 6. So those would be my two solutions, but it needs to be made equal to 0 first. Right, and that's it. I hope that's helped. And next time what we'll do is we'll look to see how we can use the quadratic formula to solve quadratics which can't be factorized, and also how to use the how to complete the square, which we'll do in a separate video as well. Right, I'll see you next time. Goodbye for now.